Hi everyone, welcome to my channel. Today we're going to show you how to make a simple light appear on your LED strip using an Arduino. This code is going to be free to use, it's going to be in the description down below, but if you guys want to learn how to code, this is how we're going to do it. First, you're going to use the IDE of Arduino. There is a video down below on how to install such a program and install the plugins that we're going to be using for the rest of the series. So, going forward, we're going to save our file, which you're going to go to the top left corner, File, and Save As. You can call it a test program. Alright, and there we go. So once you have saved your program, you're going to have a default sketch when you start something new, and it's going to show void setup, and it's going to show void loop. So for us to step forward into using the Arduino, we're going to have to import a library that will help us communicate between the chip and communicate to the Arduino Nano. For this to take place, you're going to have to download the Adafruit.Neopixel library. If you guys haven't done it, there will also be a link down below where you can find that library. But I'm assuming that you have already installed it and it's connected. So we're going to go hashtag include open crocodile bracket Adafruit underscore Neopixel .h close crocodile bracket. Alright, so it's good to know that it's all very case sensitive. So over here we have a capital A, and we have a capital N, and we have a capital P. So these are things that we need to have in order to run the code. It is very case sensitive, so please be careful not to make any mistakes as you go along. So next thing is we're going to have to tell the board on which pin is it going to communicate with the LED strip. And you can see on your board there is numbers 13 to 1. We're going to be using the D for digital pins, and I'm going to use the pin 6 as the default. So integer, which is int, data pin, that's the name I'm giving that connection, and I'm saying that we're connecting it to number 6. So we have connected the cable that transfers the data between the LED strip and the chip. Okay, and that's connected to pin number 6 on the board. Moving on, we are going to have to define how many LEDs we have on the strip. So hashtag define number of pixels, and I'm going to use 60. So if you guys have an LED strip with 120 or 7, you would change that number there to match the exact amount of LEDs that you have on your strip. Alright, after that is done, we're going to define the maximum amount of brightness. So it's hashtag define maximum brightness, and that's going to be 255. So, oh, I have misspelled it. So the interesting fact about coding is that it doesn't really matter too much if you spell something wrong, as long as you use that same misspelt character further down the name, further down on the code. So for example, my name is Alex, but if it's spelled differently, as long as you keep referring to that spelled differently Alex, you'll know that it belongs to me. Same with the code. If you give it a name, which we have named it maximum brightness is equal to 255, we will know that that is its name. But if you spell it differently every time, then it won't recognize it. After we have done that, we have to make an object. Alright, and making an object is quite simple. It's giving something a value and defining it so that it will remember that this object has this value. So we're going to make an LED strip, like a digital LED strip. So it knows when I say LED strip, it will know exactly what I'm referring to. Because I can't say my LED strip is LEDs or pixels. You can change the name to that, but I'm going to refer to the line of where your pixels are connected as an LED strip. So moving forward, we're going to go and do Adafruit underscore Neopixel okay, and needs to be caps. Neopixel space LED strip. Again, I messed up with the caps. So Adafruit.Neopixel needs to match the same as the library of which we imported. So as long as you have the library correct, you can just copy and paste it, and that should be identical. You see how it changes color? So now it's recognized it. Moving on, we're going to say is equal to Adafruit underscore Neopixel, again with a capital P, bracket number of pixels, comma, data pin, close brackets, semicolon. Okay, so you just need to make sure that your caps all line up. And let me explain what we've just done here. So we have just made an object called LED strip. Now this is what we are referring to as the strip of LEDs, the physical object that you have. We are naming it in this code as LED strip. So now the code knows that when I say LED strip, I'm referring to that line. And we need to give it more information so it knows a bit more about it. So right here I said number of pixels. So now it knows that this LED strip has the number of pixels, which we have set over here to 60. So this strip has 60 LEDs on the strip. Then we have also told it on what data pin we're communicating with. So over here we said data pin 6. So now it knows, all right, if I want to communicate to the LED strip, I need to communicate through data pin 6, and that there are 60 LEDs that are on that strip. And we have just made one object that is called LED strip. Moving on below that, we're going to have a setup function. So almost like how you bake a cake, you have to get all of your groceries ready to bake the cake. It's like the pre-setup. Over here, it's a very simple setup. It's just going to be LED strip, which is our object of LEDs, and we're going to say dot begin. All right. So now that we are beginning it, it's knowing that, all right, we're going to start using this light that is the LED strip, and it's gotten it ready. It doesn't know what to do with it yet, but it's gotten it ready to use. And so now we get to move on to the next step. Every time you power on your board, it's going to run whatever code is written in this loop. And this loop is just going to carry on running forever and forever and forever until you pull the plug. So the cool thing about this is you can write 7 lines of code, like change them blue, green, red, orange, and it will go through all of them. And then once it's finished, it will just go back to the beginning and do it over and over again without you unplugging and plugging in your board every time you want to restart the program. So we'll get to that. We're going to create a custom light color. So I'm going to make a method, which is a void custom light. Alright. I want you to then do curly open brackets, enter, and then it should generate curly close brackets. Now this method, custom light, I want you to think about it as a box, alright? So I have a box, and the box's name is custom light. Whatever's in those brackets after it is the key you need to open the box, alright? And then whatever's in the curly brackets is what's in the box. So currently, we don't need anything over here in the curly brackets to open the box, and currently there is nothing in the box, but the box's name is custom light. Alright? Cool. So let's go in and make another box. This box we're going to name is set lights to color. So we're going to go void set lights to color. Alright. And for you to open this box, I want you to give me a number for red. I want you I want you to give me a number for blue, and I need a number for green. Okay. And so normally how this works is it refers to RGB, so blue should be at the end, and green should be in the middle. So then you have to do curly brackets, enter, and it closes the curly bracket. So we have made a second box, which is a method. The method's name is set lights to color. And for us to open this box, we need a red, a green, and a blue. Alright? And that refers to the RGB colors, which is from 0 to 255. So if I just wanted red, I would put in 255 for red and 00 for the other two colors, and I will just get red. So let's do that. I want to set set lights to color, and then make sure that you refer to it exactly how you named the box. And we need a red, a green, and a blue. So I'm going to make a custom color, and let's go with 250, comma 20,0. Alright, so over here I've asked for 250 red, a 20 green, and a 0 blue. So we're going to get a mixture between red and green, but like very little green, the max being 255. And now we're going to open the box, because we have a color for red, we have a color for green, and we have a color for blue. So we've opened this box, but there's nothing in the box. It doesn't know what to do. So over here we're going to try and add that color to every LED on that strip. Okay, so for us to begin this procedure, we're going to make another loop, which is referred to as a for loop. So for unit _t I equal to 0, semicolon, I smaller than number of pixels, semicolon, I plus plus, close brackets, enter, curly brackets, enter, and now you'll see another curly bracket appear. So we have made an object named I. I has the value of 0. So 0 is smaller than number of pixels, which is 60. Is 0 smaller than 60? Yes. So it will proceed to the loop. Then the I++ will add one number to I when it's finished and goes back to the top. So I is equal to 1. Is 1 smaller than 60? Yes. And it's going to proceed with this loop until I, which is equal to 60 eventually. Is 60 smaller than 60? No. So it's going to stop the loop and proceed with the code. Now the reason why we've added this is we don't want it to go on forever. We only have 60 LEDs on our strip, so there's no point of the computer doing calculations for 61, 62, and 63 if we don't have those LEDs to work with. So moving on, we are going to now have to change the color, which we're going to use is LED strip dot set pixel color bracket I, comma, LED strip dot color bracket red, green, blue, bracket bracket semicolon. Alright, so we are referring to our LED strip, okay? We are setting a pixel color. Alright, 1 pixel on that LED strip, we're changing its color. And which pixel are we changing? We are changing pixel I. We are changing the light to this color, which is red, green, and blue. So you remember we had to open the box with 3 numbers, which is 250, 20, and 0. That information is getting passed into these brackets. And it's going to make red equal to 250, it's going to make green equal to 20, and it's going to make blue equal to 0. So that information is there. We're then changing that 1 pixel on that strip, that color. So if I is equal to 0, over here it's going to make 0 the first pixel on this strip. It's going to change that color. And then it's going to finish the loop and go back to the top, which now I is equal to 1. And then it's going to change the second pixel on that strip to that color. And it's going to proceed doing this until you reached your 60. And once all of the lights have changed to that color, it will stop the code. Okay, awesome. Now, once you have changed this, you actually have to show your results. So after your for loop over here, we're going to write LED strip dot show bracket bracket semicolon. So what this has done is it's going to show all of the changes that has been done. Sometimes it will make some changes, but you haven't shown it to, you haven't told it to show it. So if you move this line of code, LED strip dot show, into your for loop, it will show you every time it will light up individual lights. But we don't want that. We want the whole strip to light up, and then we want to see it. So this is what we do. We say LED strip dot show, which will make the whole LED strip show after the changes have been done to every single pixel. Alright, now you remember I said void loop, this is what happens every time you start or plug it in. Well, we currently have nothing in the loop, so if we ran the code now, nothing would happen. To get past this, we're going to call custom color or custom light. Okay. So when we plug in the loop will run, which is going to call the box custom lights. Custom lights doesn't need any key to open it, so we put nothing in the brackets. Then it's going to run the code that's inside of it, which is set lights to color. Okay? And this requires a key. It requires numbers for it to open. So it's going to need 250, 20, and 0. You can change these numbers if you like, but for my color, I want this. We're then going to make red equal to 250, green's going to be equal to 20, and blue's going to be equal to 0. In our loop, which starts at 0, it's going to change every single pixel to match that color that you've mentioned above. And after it's mentioned above, it will show it all under LED strip.show. Once that is done, your lights will show as one color. And this will be infinity, so as long as your board is powered up, it will constantly show that one color. This is crucial. We're going to click the compile button, which is the tick on the top left corner. Alright. There were two issues that had appeared with my code. The first one is I spelled include wrong, so you need to make sure that you have the D in include. And second of all, the semicolon at the end of set lights to color. Once you have fixed those two issues, you should click it again and you'll see it saying done compiling. Now, for you to add this code to your Arduino, you're going to click on Tools, you're going to go to Board and select your board below. For me, we're going to be using the Arduino Nano. Then you're going to make sure you have the old bootloader selected, and then under ports, once you have plugged in your USB, you can go to Tools, alright? Make sure that it is on COM5. For me, it's on COM5 because I've plugged it into the 5th port on my computer. You might have COM3 or COM1 or COM2. That's all okay, you just need to select the right COM. Once again, if your thing is compiled completely and right, then you can click on the arrow. Now this will update your code to your Arduino. And once that is done, you can plug in your Arduino into your LED lights and it should work smoothly. As you can see at the bottom, it says done compiling or done uploading, and it is using the Arduino Nano, the old bootloader, and on COM5 at the bottom. Cool. So I hope that was helpful for you guys. If you enjoyed the video I have made, there's a link down below if you want to download the code for this, and if you need any questions answered, please message them down below. I'm more than happy to help you where I can. And yeah, like, comment, and subscribe, and see you all in the next video. Bye.